Hey there, ladies and gentlemen. Today is 9-4, multiplying rational expressions. So go ahead and pause here so you can write this part down, and then I'll expect you to come right back. All right, so hopefully you got that paused and written down. Multiplying rational expressions, multiply the numerators, the tops, multiply the denominators, the bottoms, and then simplify it. This, we can't forget though to write our excluded values, and you always do your excluded values before we cancel anything or simplify anything. So if we look here, in both of these, they're monomials, so these are the easy ones. So we just say A doesn't equal 0, B doesn't equal 0, and C doesn't equal 0, because they're all just being multiplied, and if you multiply anything by 0, it turns it into 0. Then it says multiply the numerators. So 5 times 16, we get 80. And then there's no multiple of the A's, so it stays A. There's no multiples of the B, and there's no multiples of the C. So they just stay as they were. We go ahead and we take 8 times 15, and that gives us 120. And again, we just have one of each variable. So just go ahead and jot those down then. Then we are looking for simplifying this rational expression. 80 over 120. If you go ahead and reduce that, we get 2, oops, that's fancy, 2 over 3. Then we look at our A's. Which one has more, the top or the bottom? In this case, the bottom does, and how many more are on the bottom? One of them. Then we look at our B's. We have B cubed on top, B on bottom. Which has more? Well, the numerator has more by 2. And then we have C to the third on top and C squared on bottom. Which one has more? Well, the numerator does by 1. Okay, so I'm going to show you this same problem, but I'm going to simplify it first and then multiply. So a little bit different, and as always, it doesn't matter to me which order or which way you do it. The first way I showed you or the second way I'm going to show you, as long as you're getting to the right answer, that is great. All right, so I'm going to look at this and I'm going to ask myself if I can simplify anything first, and that has to be from the numerator to the denominator. So I know 5 and 15 are going to simplify. 5 goes into 5 once, and 5 goes into 15 3 times. If I look at my 16 and my 8, 8 goes into both of them. 8 goes in there once and into there twice. So then my variables, we do it the exact same as we did in the previous one. I have an A on top and an A squared on bottom. So there's 1 on the bottom. I have a B cubed on top and a B on bottom. So there's 2, and that one goes away. And then we have a C squared and a C cubed, so that goes away. So I end up with, now the tricky part with doing it this way is just making sure you don't miss anything. So we get 2b squared c over 3a. And good, we did end up with the same thing. All right, so I'm going to give you guys a chance to try problem 2 here on your own. Go ahead and pause it and see if you can come up with the solution. All right, so all I did is write up there your excluded values. Again, with this, they're just being multiplied, so everyone cannot equal 0. Okay, so I multiplied them here. We get 48 g to the fourth h to the fourth over 256 g h to the third j squared. So now you're going ahead and you're looking for simplifying. Well, 48 over 256, if you're not sure about that, that's fine. Just put it in your calculator and have it reduce it for you. So we get a 3 in the numerator and a 16 in the denominator. I have a g to the fourth on top and a g on the bottom, so that gives me g to the third. I have an h to the fourth on top and an h to the third on the bottom, so the top has 1 more, and then there's no other j. So 2 parts for that answer. All right, go ahead and jot down this next part here. This one's talking about our multiplying rational expressions, but this time they have a polynomial. So go ahead and pause here and get this jotted down. All right, so hopefully you pause. The biggest things are factor, then we do excluded values, and then we simplify. So you're going to factor first, and that makes it easier for us to find our excluded values, and then we cancel things out. So if we look at our first example here, the only place we can factor is in this denominator. So multiplies to negative 15 and adds to negative 2. Those are going to be negative 5 and positive 3. So I'm going to cross that out, and I'm going to put x minus 5 and x plus 3 in my denominator now. Now, so I factored, that's the only thing I can factor. Now I do my excluded values. Excluded values, just a reminder, is only dealing with the denominator. So we would say x cannot equal, and then we kind of look at the first one. We have just an x by itself, and so we can't have that be a 0. Then we have x minus 5. So think back here to the last lesson we talked about excluded values. X minus 5, so x cannot be positive 5. That would make that into a 0. And then we have x plus 3, so x cannot equal negative 3. That would make that into a 0. All right, now we just go ahead and we're going to simplify anything that's in the numerator with the denominator. So I have an x minus 5 in both of them. And then I notice I have an x squared on top and an x on bottom. So that's going to cancel one of those x's out. So now we are left with x over x plus 3. This is our solution. Now, many people have asked me, well, can I just cancel those x's out? And we can't. That x in the bottom, x plus 3, it's like it's married to the 3. It's attached. They are super glued together. Whatever you want to say, they are stuck together. You can't do anything to simplify them. And I'm going to show you a numeric example of why that wouldn't work. All right, so all I did was substitute 5 in for x. So if you went through and canceled the 5s, then you would be left with a 1 on the top and a 3 on the bottom. But now if we go back in, that's really 5 over 8. Can I simplify 5 over 8 into 1/3? No, those are not equivalent. So there's a numeric example as to why I can't cancel those two x's out. So I'm going to leave them. All right. Let's go ahead and look down here at this next problem and look for anything that I can factor. And so I can factor just the bottom again in this other one, multiplies to 12 and adds to 7, and that ends up being 3 and 4. So we get x plus 3 and x plus 4. All right, go ahead and pause here and see if you can come up with those excluded values. All right, so we get x cannot equal 0, x cannot equal negative 3, and negative 4. Remember, the negative 3 and the negative 4 come from, if I plug those in, that term would turn into a 0. All right, so we're going to cancel my x plus 3's, and that's about it. So we get 5 on the numerator, and then an x times an x plus 4. Now, I am okay if you wanted to leave it this way. If you wanted to distribute in that x again, you would have x plus 4, x squared plus 4x. Both of those are going to be equivalent, and both of those are going to be accepted answers. All right, so now we're looking at this next problem, and this next problem has more factoring to do to it, and that's just fine. We are going to see that we need to factor this top one here. Multiplies to negative 4 and adds to a negative 3. Well, that's going to be a negative 4 and a positive 1. So y minus 4 and y plus 1. Now in my numerator, the y plus 5 we keep. My denominator, y plus 5, we keep. And now in this bottom one here, we're going to factor out a y. Now, just a reminder, if that had said y squared minus 4, that's a difference of perfect squares. We'd get y plus 2 and y minus 2. But it was a y squared minus 4y, so I could take a y out of both of those. All right, so the next thing is our excluded values. So we have y plus 5, so we'd say y cannot equal negative 5. We have a y, so it can't equal 0, and then y minus 4, so it can't equal a positive 4. All right, so now I'm going to cancel out my y minus 4s and my y plus 5s. And I'm left with y plus 1 in my numerator and a y in the denominator. And stop there. Remember, we cannot cancel those y's out. All right. And I'm going to give you guys some time to try this one on your own. You are going to end up factoring 3 out of the 4 portions of the fractions. So go ahead and pause here and come back and join us in a little bit. Okay, so I factored it. I wrote our excluded values. The positive 3 comes from here, the positive 10 from here, and the negative 3 from here. All right, so hopefully you had gotten to this point. If you didn't, pause it and go in and check yours and fix it. If you are at this point, let's go ahead and do some canceling together. So I'm going to cancel out the plus 3's, the minus 3's, and I'm left with b minus 1 over 4 times b minus 10. I would leave it at this point. You are more than welcome to change it into 4b minus 40. Oop, there we go. Both are equivalent. All right, let's go into doing some word problems. So what we are doing here is we're really focusing mainly on converting, and we're using our labels to do most of this. So it's going to be similar, but a little bit different than what we were working on. All right, so there are 25 lights around a patio. Each light is 40 watts. The cost of electricity is 15 cents per kilowatt hour, and write an expression to calculate the cost of using the lights for 3 hours. So we have 25 lights, and each light is 40 watts. So we're going to say 40 watts per one light. Now, we want to see that we are going to be canceling out some labels here. Okay, so our goal was to have one in the numerator and one in the denominator. So now I have it in watts, and I need to make it, we talk about kilowatts here. So I need to change watts into kilowatts. So watts is in my numerator, so I'm going to put watts in my denominator and kilowatts in my numerator. Remember, kilo or kilo is 1,000. So for 1 kilowatt is 1,000 watts. So we'll see our watts cancel. And then it says it's 15 cents per kilowatt hour. So we changed it to kilowatts. So we're going to say 15 cents per 1 kilowatt hour. So kilowatts are going to cancel. And then the last thing says find the expression for 3 hours. So we're going to put in times 3 hours. And that's where we see the hour portion of that cancel. So now we go ahead and look at our numbers. 25 times 40, and then times 1, but I don't really need to write that. Times 15 times 3 are my numerators, and my denominator is 1,000. And notice the only label that I have left is cents, which is perfect because it says write an expression to calculate the cost. So we want our answer to be in money. All right, so go ahead and type this in your calculator. If you're going to do it all in one, you're going to want to put that numerator in parentheses. All right, so hopefully you were able to work that down. Now, if you didn't put it all in one, 25 times 40 is actually 1,000. So those are going to cancel, and we end up with 45, and then our label is cents. And if you wanted to put it in, it could do 45 cents or a dollar sign and 0.45. All of those show 45 cents. All right, so let's go ahead and jump to the next problem. It says in the 2004 Summer Olympics in Athens, Greece, Justin Gatlin of the United States won gold medal for the 100-meter sprint. His winning time was 9.85 seconds. What's his speed in kilometers per hour? So we are going to take his 100-meter sprint, and it's per 9.85 seconds. And we want to change meters into kilometers and seconds into hours. All right, so let's do meters first. So meter is in the numerator, and I'm going to write meter in the denominator, and then kilometer is going to go in the numerator. So we just talked last slide, kilo is 1,000. So 1 kilometer is 1,000 meters. You know what? If you don't remember that, you can Google it, okay? There's nothing wrong than looking that up. Don't procrastinate on doing a problem when you could look that part up, okay? All right, so meter is going to cancel. So we are in kilometers, which is part of our answer. Now we want to make it into hours. So we have seconds. And so you could do this two ways. You could do one, convert seconds into minutes and minutes into hours, or we can do that all in one and go from second to hours. So how many seconds are in 1 hour? Well, there are 60 seconds in a minute, and there are 60 minutes in an hour. So 60 times 60 tells us there are 3,600 seconds in 1 hour. seconds cancels. So now we're going to be left with 100 times 3,000. Oops, got a little happy with my zeros. Times 3,600 over 9.85 times 1,000. Now, if you're going to type it all in your calculator in one, go ahead and put that into parentheses in the numerator and the denominator. And then notice it does say it requests you to go to the nearest hundredth. All right, so hopefully you ended up with 36.55 kilometers per hour. All right, last problem here, guys. The velocity that a spacecraft must travel in order to escape the Earth's gravitational pull is called the escape velocity. The escape velocity for a spacecraft leaving Earth is about 40,320 kilometers per hour. What is its speed in meters per second? So we're just going to go backwards from what we did on the last problem. We are starting in kilometers per hour and we're working towards meters per second. So 40,320 kilometers per 1 hour. All right, so I want you to see if you can set it up to convert it into meters per second. So pause it here and then use your previous problem to kind of work backwards from and see how you do. Okay, so I've got mine set up. Check it out, make a little tweak on yours, and if yours looks good, then make sure that you have done your multiplication properly, and we should see you get 11,200 meters per second. All right, there you have it, ladies and gentlemen.